All right. So let's go ahead and get into this intro to JavaScript class. First, just a little bit of an introduction. This is me. I'm Erik Gross, co-founder of the Tech Academy, longtime software developer, U.S. Navy veteran. I was a nuclear reactor operator and electronics technician in the Navy. Lots of stories I could tell about that, but I'll share just one thing that I don't know if I've shared very much before in some of these free classes. I went through nuclear power school, electronics school, got picked up as an instructor at a nuclear power training facility out in the desert in Idaho. And about a year into my time of being an instructor, the Navy picked me to attend a special school that sounds really boring, but changed my life. It's called Electronics Technician Maintenance School. A really boring name and an amazing school. Only 10 people a year go to this school out of the entire nuclear power community, 5 at a time, twice a year. And there's a point to my telling this story, okay? What they do at these schools is they have a big lab and instructors, and they keep track of all of the really severe equipment failures or issues that have happened out in the fleet, out in the actual operating ships of the Navy. Things that caused a lot of operational downtime or put a ship in jeopardy or were super expensive to fix or were extremely difficult to fix. What they do is they ship all that same equipment out to this big laboratory, and the instructors replicate the exact failures that happened out in the fleet. And all week long, all you do is go into a very, very brief classroom thing where they just orient you to some principles of diagnosing complex systems. And then they give you a one-sentence description of the first point where someone on a ship saw something go wrong. And your job as a team is to go in and figure out exactly what happened and fix it. And they're always really, really gnarly problems. So besides getting a lot of practical experience of digging around inside electronic equipment, electromechanical devices, and all this sort of thing, the part that I really, really took away, and this affected all of how I do engineering and how I teach engineering, is this. There are fundamental principles involved in any complex engineering activity. And if you understand those fundamental principles, you can break down what initially looks like a very complex situation or a complex problem and rapidly isolate the vital information. And we did it over and over and over again. The same mental approach to diagnosing a complex system was used every time. And that's the thing I took away is it doesn't really matter what the situation is involving a complex system. If you have the fundamentals really, really down, you can confront that level of complexity. And I bring this up because what we do in these classes is try to impart some of those fundamental principles. These classes are an hour or an hour and a half. We're not going to get into a tremendous amount of fundamental principles. But the fact is that if you just walk away from this class learning a couple of really important basic principles behind computers and programming, it could affect your whole technology career. Or even if you don't go into technology, it will affect how you interact with computers. So again, I don't usually go into that background, but I just want to share that so you kind of have some context for why we do these classes, and more importantly, how we approach the teaching process at the Tech Academy. All right, let's move on. Some housekeeping things. Basic guidelines for the class. We have an assistant in the class. You'll see Cheska in there. All right, she monitors the chat, helps answer questions, make sure I don't miss anything, and drops links in the chat when we need them, that sort of thing. Please be nice to her, me, and everyone else in the class. I want to point out that certain parts of this may be challenging to you. You might run into issues where you're like not quite grasping it. And I do try to make it as understandable as possible, but just bear in mind that part of the learning process is working through those challenges. So pay close attention, go slow, I'll go slow, use chat as needed, and you will get through this. One of the most important pieces of advice in that, though, is when we are writing code, we're going to cover a few things and we're going to write some code. When we're writing code, please be sure to type code exactly as written. Computers cannot figure things out. They'll only do exactly what you tell them to do. And what this means is things like a misspelled word, a missing symbol, even something capitalized that shouldn't be capitalized can result in errors in your code. So when I'm typing stuff out, go slowly and type exactly what I type. Another thing that can really help is make sure that you're in a distraction-free environment and you can focus on the class so I don't lose you. And if you fall behind, don't freak out. Don't worry about it. Just listen and learn. Stick around because you will still learn a lot, even if you've lost track of all the typing that's being done with the code. It's totally fine. Pay attention and learn. Often we get asked whether we record these and if the recordings are available, and the answer is yes and yes. Usually within a day, the recordings are up on our free YouTube channel, and you get links to that at the end of the class. You'll also get the full set of code for the game we're going to examine today, and you'll be able to play that game and go deep into that code if you want to. Okay. Finally, we're going to give you links to everything at the end of the class: future events, free videos, other resources. So stick around. I think I've already had a few people just let me know where they're joining us from. But if you're new to this, if you've never attended one of our free classes, please drop into chat right now and let me know where you're joining us from. I'm in Slidell, Louisiana, right near Lake Pontchartrain, like 300 feet from it, which means when the hurricane came through about a month ago, we got like 3 or 4 feet of flooding. St. Louis, Missouri, I love that town. Very cool. All right, have a sip of water. Okay, so here's the basic agenda. We're going to go over a short explanation of the Tech Academy, who and what we are, and then we're going to write some code. I try to answer questions while we're doing the coding, but if there's stuff we don't capture or I don't get to, we'll have a brief Q&A session after the coding, and we'll then go over some information about our boot camps. We've got 12 different boot camps. There is a free gift waiting for you at the end. Stick around, and you're going to want this gift. It's actually really, really cool. The whole class should be about an hour and a half. All right, so short introduction to the Tech Academy. We deliver boot camps. If you're not familiar, coding boot camps are intensive technology training programs. They're designed to prepare people for entry-level careers in tech. Typically, depending upon where you go, they can last anywhere between 3 and 6 months, sometimes longer. They all focus on practical, modern skills. They teach you what you need to be part of a development team and use modern tools. At the Tech Academy, we've been offering really thorough, budget-friendly, flexible, very trusted coding boot camps for over a decade now. It'll be 11 years pretty soon, which is pretty cool. The programs are cost-effective. This part's important. I'll tell you more about it later. Our programs are self-paced, which is really unique, actually. And they're tailored for beginners, people who have no prior coding or technical knowledge. They cover really in-demand skills. They're endorsed by stellar online reviews. They're flexible enough to fit around your personal schedule. And we specifically try to give you a very well-rounded toolkit so you're prepared for a long-term career. In terms of price, we're well below the national average. The national average for boot camps is around $13,000 or $14,000 in America. We're way under that. We have boot camps that start as low as $59.80. And I always like to read our mission statement. My co-founder and I, Jack, came up with this over 10 years ago, and it still is true today. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. All right, so let's get started. we're going to have a brief little like education piece here, part of which is extremely important. And then we're going to get our hands dirty writing some code. We're going to start with some really basic terms. First of which is a program. It's just some written instructions that when you enter them into the computer can make it perform specific tasks. That's actually kind of cool. One of the things you will learn about if you enroll one of our boot camps is that computers actually can only perform about 24 instructions. And the instructions they can do are not written in English. But what programs allow you to do is write some instructions with English words, and you can turn them into what makes the computer do work. It puts you in charge of the computer instead of having to deal with whatever the computer has been pre-programmed to do. You're in charge. It's really cool. The next word to cover is programming, programming language. This is, and there's many of them, an organized system of words, phrases, and symbols. These are the instructions that you enter into the computer. This is how you make a program, is with a programming language, right? There's lots of them, like I said, thousands. There's probably 20 that are really popular around the world. And then there's a verb coding. This is just the action of entering those instructions in, literally typing them up. That's coding. The instructions you type in, those, you can call that code. So here's some basic terms. Probably most of you are familiar with those terms, but now we're going to get into a little more specific stuff. The language, again, there's lots of programming languages. The language we're going to use tonight is called JavaScript, and it's actually more popular today than it ever has been. And there's a lot of backstory behind that, but in the beginning, in the mid-90s, when JavaScript came about, it was only used to add special functionality to web pages. Beginning about 15 years ago, some really cool technology developments happened, and now you can use JavaScript to create almost any kind of computer program, which makes it really valuable. It's also relatively easy to learn. There's another technology. It's not a programming language, but it's called HTML. That stands for Hypertext Markup Language. Simply put, this is a set of instructions you can type into a computer that describe the content and appearance on a web page. It's how you make a web page, which is pretty cool. Now, how do you style the web page? How do you make all the colors really cool and put cool borders around pictures and change the font and all that kind of stuff? Well, you do that with another technology called CSS. This stands for Cascading Style Sheets. And again, on our boot camps, you'll learn everything about these technologies. But the point I want to make is that these three technologies together are the heart of web development. These are the things you need to know and know well to do web development. In fact, we casually refer to these three technologies as the Holy Trinity of web development. It's not an official title. It's just something that a lot of people in web development do. So this is a JavaScript class. You saw that in the name when you signed up for the class. So the language you're going to use to program some stuff is JavaScript, but you're going to see a little bit of HTML and CSS. And I'll point them out when we see them. Now, those of you who've attended my free classes before pretty much know exactly what I'm going to say here. I'm going to say it again. The data we're going to go over on this slide is some of the most important data you will ever learn in the field of computer programming. Period. End of sentence. It's going to seem remarkably simple, but I've found in the 44 years that I've been programming computers that the most important knowledge you'll ever learn is fundamental, simple, basic knowledge. And if you have that down cold, everything else about your career goes well. So we're going to cover some rock bottom fundamentals. What we're going to cover here is, as it says there, what are the 5 elements of any computer program? And I mean any computer program. And they're all vital. Now, we're not going to go into deep detail on every one. You can have an opportunity to do so at the end of the class that I'll tell you about. But we are going to cover the basic concepts here, and they're real important, like I said. The first fundamental element of any computer program is just an entrance point. In other words, it's the first instruction that gets performed when you double click on the icon and turn on the program. When you start a program, there's got to be a first instruction. Now, one of the reasons this is really important is that when you do start a program, when that first instruction executes, something really cool happens under the hood. And when I say under the hood, I mean on the computer. There's my computer. On the computer that the program is running on. And here's what happens specifically. Your program is going to work with data. All programs work with data, right? And that data needs to be stored somewhere while the computer program is running. The place it's stored is inside some physical, devices inside your computer called memory devices. Pretty straightforward. And they have a lot of locations in these memory devices where you can store data, but there is a finite number of the locations. And so when you start a computer program, what happens is that a certain amount of those available memory spots, those memory locations, gets reserved just for your program. No other program can touch them. It protects the data that your program might need to store in the device. So that's kind of important to know. The thing that can help you as a developer is this. When you are trying to figure out how a computer program works, let's say you didn't write it, you just inherited it, you joined a team, and there's this big computer program that you're responsible for. When you're trying to figure out how that computer program works, one of the most effective things you can do is find the first instruction. See what it does as soon as you turn on the program, and then follow one instruction at a time to really start to grasp how the program starts up and what it does as it runs. So if you can learn for any given program or any given programming language, how do I find the first instruction? You have a valuable tool. So that's the first thing. Hey, Mark, I see that you have your hand raised. If you have a question, drop it in the chat and I'll pay attention to it, okay? I'll watch that. Let's move on to the next fundamental element of any computer program. It's called variables. A variable is just a piece of data that a program keeps track of, where the data could change while the program is running. This is actually super important. Normally, you're creating a computer program to automate something you could do manually. And we deal in human business and personal work with a lot of data, and very often we are changing the data we work with. So a variable is part of a computer program where you can keep track of data that's going to change. More importantly, your program can keep track of data that's going to change. Without these, a program is not very valuable to you or any human being, really. Another fundamental element of any computer program is control and branching instructions. This is how you get a computer program to make a decision. You can control which of two or more available branches of instruction the computer takes. You're going to see all this in code. You're actually going to write these in a few minutes here. But without this kind of a construct, a control and branching construct in a program, the program has very limited value because we're often creating a program to automate decision making. If the amount of items in a shopping cart exceeds $200, then automatically apply free shipping, as an example. You've got to build that into a program. And without the ability to control whether or not that discount is applied, the program isn't as valuable. The next fundamental element of any computer program is what are called subprograms. And like it says, you can consider, like it says here, you can consider a subprogram a program within a program. They're really nifty. They're very valuable. And without them, life is very hard for you as a computer programmer. What's a subprogram really? Well, it's this. If you're writing a computer program and you're finding that there's a series of instructions that you're entering in over and over again, and they're the exact same instructions, and you're using that same set of identical instructions many different places in your program, you're going to want to bundle up all those instructions into a little box, if you will, called a subprogram, give it a name, and then whenever you need that exact set of instructions to happen in your program, you don't have to type them all out again. You can just say, hey, do this subprogram right here, and when you're done, come back where you left off. You're also going to build this tonight, and it's very, very, very powerful. Without this in your programs are very hard to maintain and not as valuable to human beings. Finally, the last fundamental element of any computer program is an exit point. There has to be a final instruction, just like there was a beginning instruction, there has to be an ending instruction. The chief value here is that when that ending instruction is hit, you know that the underlying computer that your program is running on is now going to release some of those memory device locations, make them available to other computers, other computer programs. So here's your 5 fundamental elements of any computer program. And you will not find anything in any computer program that isn't one of these 5. That's pretty cool. So if you know these 5 things really well, your journey of learning a programming language, learning to create programs can be made a little bit easier. All right, let's move on and start to write some code. Now, to write some code, you're going to need to be able to have somewhere to write and edit the code. It's called a code editor, right? So we're going to drop a link into chat right now, and I want you to click on it. There it is. That's going to open up a window that looks kind of like this that you see on the right-hand side. You're going to see 2 different like sections or panes, P-A-N-E. On the left is where the code is. Ignore all the code that you're going to see there. We're going to get rid of that and start over, okay? On the left is where you put code. Hold on a second. And on the right is output. Now, this part's really important. And by the way, if you have 2 monitors, this is going to be a lot easier. I want you all to be able to see on the left my code and on the right your code. If you have 2 monitors, that's easy. Drag your Zoom application where my smiling face is, or rather where this slide deck is, drag it over to one monitor, and then put your browser that's opened up to this code editor, put it on the right. But if you don't have that, you're going to have to do it side by side on one monitor. If you're having trouble doing that, you'll find that to resize the Zoom window, you might have to click on the word Zoom meeting and then restore. That'll let you resize the Zoom window. And to resize your browser, look in the top right of your browser. You'll often see a little symbol that lets you resize it. It's like 2 different squares on top of each other. And you're going to want to get both of these side by side. I'm going to give a moment for everybody to get all situated with their code editor on the with me on the left and this code editor on the right. Cheska, can you take a note down, please? This animation in this specific slide deck is not the one I want. Look in last week's slide deck and you'll find one that's a much better illustration of how to resize a browser. So please take note of that. And let's change this slide deck. All right, I'm going to switch over to my code editor right here. And I want you to do what I did. I just want you to do a Control A in here and erase all the code. Okay? Oh, hold on just a second. Wrong editor. You probably all have the right link. I had the wrong one and I apologize. This is what we see right here. Okay, good. So here's what I want you to do. I'm going to copy this code. I'm going to go to chat right now. I'm going to select everyone. I'm going to paste this code. And I want all of you to copy that code and paste it right in here. I'm going to give everybody a moment to do that. All right. I'm going to watch chat here. Is this working for you? Did you get the code in there? If it's not working for you, if you couldn't copy the code, tell me no in chat. I want to know. I got a yes. Good. Got some more yeses. Okay, good. Now let me explain what we're looking at before we start writing code. And I think I might want to do a Control plus to make it larger. Is that readable? Pooja says not able to copy. Pooja, if you scroll up, let's see. You can't copy it. You might have to just drag your cursor from the top to the bottom and do a Control C or Command C to copy it all. I'm going to give Pooja a moment. I want her to be caught up. While you're trying to get that, Pooja, let me explain what we're looking at here. What you're looking at is mostly HTML. Now, I mentioned HTML is not an actual programming language. It's called a markup language, and it is the way that we create web pages. Now, what's interesting is this part right here that begins with script and ends with /script. Everything else besides this section that I've highlighted is all about what's on the page. Things like where it says my heading, that's a headline. Things like where it says play around with the code, that's a paragraph. That's all about the content and appearance of the page. But what's inside this area that says script is actual JavaScript. Those lines of code that I have highlighted are JavaScript. And so when we start playing around in between these script areas, when we start writing our code will run and we'll be able to see the result over here on the right. So here's what we're going to do. Pay very close attention to this next part. I want you to erase the 3 lines that begin with let. And now we're going to start to control what this program does. I want to explain this section of code right here. On this web page, because again, all this stuff on the left here, this is all describing a web page. On this web page, there's going to be a part of the web page that has a specific ID. It's got a unique identifier. That unique identifier is the word demo. You don't need to know HTML, really, to understand that. There's an ID, and it's equal to the word demo. What this line of code does, and again, this is a line of JavaScript code, is it goes through the page, and it finds something on the page that has an ID of demo. Well, there it is. This thing on the page, this paragraph, has an ID of demo. And then it goes inside this thing and there's an aspect of this item on the page, there's an aspect of this paragraph, which is what's the content of it? What does it say in this paragraph? That aspect of the paragraph is called the inner HTML. And you can see that what we're doing is we're setting that to this text here, the value of z is. So I want you to erase everything up until the equals sign. I'll wait a moment till everybody gets caught up. And now I want you to do double quotes. Hello from, and then do your name and another double quote and a semicolon. I'll explain what this does. What we're doing is we're grabbing this paragraph on the page and we are using JavaScript to put content right inside it. We could type something here if we wanted to, blah, 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 blah. But instead, we're going to use programming to put whatever we want inside this paragraph. If we run this, hello from your name should appear right here. Why? Because you used JavaScript to actually change the contents of this paragraph. It's pretty cool. Here's a paragraph that we can't change. But here's a paragraph that we can. And the reason we can change this paragraph is because, one, we gave the paragraph a unique identifier. By the way, you can't have any other paragraph on this page with the ID of demo, or JavaScript won't know what to do. JavaScript is being told by this code right here, go through the whole document, find the part of the document that has an ID of demo, and then do something with it. So this is the first instruction in our program. It's the first time we did something. Go ahead and change it. Change it to Bob. Everybody say Bob and then run it. Now it says hello from Bob. All right, now that's kind of boring. Totally got it. Let's do something a little more valuable. Let's go down here and we're going to make a variable. I talked about variables before. In JavaScript, one of the ways you can make a variable is by using the JavaScript instruction var. That means variable. So type that out. And then you have to come up with a name for your variable. Now we're going to type this whole thing out, get it to run, and then I explain a few basic principles behind this. You're going to do an equal sign, and I want you to do some double quotes and do my name is Fred. Just do that. And a semicolon. But you should probably spell is correctly, unlike me. And I want to explain a bit of what's happening here when everybody's done. It might seem like a relatively straightforward line of JavaScript code. And it is. But there's two things that occur on this line of code that if you understand each of the two things, again, can deepen your knowledge of programming and make your learning journey a little bit easier. So let me explain the two things that are occurring. There's a thing that occurs before the equal symbol, and there's something that occurs including the equal symbol and afterwards. Here's the first thing that occurs. Oh, wait, I messed up. After the word var, type MSG. That's the name of our variable. I messed up and I apologize. So there's two things that are happening here. Let's explain what's happening in this highlighted section of our code. I mentioned the importance of variables, the importance of having a way inside your program to keep track of data that can change as your program runs. And the way this works in JavaScript is this. We're going to use the JavaScript instruction var, stands for variable, and then we're going to come up with a name for our variable. Now, let me illustrate with just an analogy what's happening, and then I'll tell you exactly what happens inside the computer. Here's the analogy. You can think of a variable as like a bucket. Well, it's not a bucket, it's a cup, but think of like there's a bucket here. On the outside of the bucket, you're going to put a unique name. That's our variable name. On the inside of the bucket, you're going to put the actual information that you want to store, the actual information you want to keep track of, the actual information that could change as our program runs. So that's the analogy. Here's what happens for real. Inside your computer, again, are these little devices called memory devices. You may have heard them referred to as RAM. It stands for random access memory. They're little devices about 3 or 4 inches long, and inside those devices are little locations where you can store information. There's usually like 3 or 4 billion locations on one of these devices. Computers deal with really small pieces of equipment, right? But the point is this: each one of those individual locations, maybe there's 4 billion of them on one of these devices, each one is a unique place where you can store information. And so what we're doing with this first section of this code is we're choosing one of those locations and we're giving the location a name. That name is message, the letters MSG. But the thing we haven't done yet is put any information in that location. That's what this symbol does. It says, hey, whatever comes after this symbol is the information to store in the memory location. And our information is some characters, they're called a string, that gets stored inside that memory location. Now again, some of you may be going, oh, this is really cool. Some of you may be going, Eric, that's really, really, really simple. And you're both right. But here's why this is important. The terminology involved is actually pretty good to know here. This part of the instruction, var MSG, where you're creating a variable, that is called declaring a variable. And all you've done at that point is choose a specific unique identifier for a location in the memory where you could store information if you wanted to, but you haven't stored any information in there. There's no value inside that location. This symbol is a JavaScript symbol, and it does what's called assigning a value. Whatever the variable is on the left of this symbol says, take the data on the right and put it inside the variable on the left. We are assigning a value to a variable. So again, the two words, this is declaring a variable. This is assigning a value to the variable. And the semicolon just tells JavaScript, I'm done with that instruction. So now that we have a variable and we put some data inside it, let's use that data. We're going to repeat the same line of code that's up above here. I want you to type it out though. It's got to be done the exact same way. Document.get. Make sure you capitalize or don't capitalize exactly the same way. Make sure it's identical. If you're at all worried, you could copy and paste it. But then put the name of your variable and a semicolon. And now I want you to run this. If everything was typed correctly, you should have "my name is Fred" appearing over on the screen. But remember, we want to keep track of data that can change. Let's change the data in our variable. Go to the bottom here, hit enter. And now, how do you change the variable, the data in the variable? Type out the name of the variable and use the assignment instruction and give it a new variable. I want to get ice cream. Now, don't hit run. I want to test a couple of things. In chat, I would like you to guess what's going to display right over here on the right when we run this code. Put your guess into chat. Only I will see it. Well, me and Cheska. Put your guess of what will happen over in chat. What will it say right at this spot on our screen? Norma, that's correct. Matthew, that's not correct. Now I'll explain why. Any more guesses? Okay. Crystal, that's not right, and we'll explain why. Okay, so let's talk about this. Go ahead and run it, and you'll notice it still says my name is Fred. There's a powerfully important lesson in this. So let's step through it very, very, very deliberately. Remember that a computer reads through a program one instruction at a time, does one instruction at a time. And it starts at the top here. This is the first instruction in our program. So even though you didn't see it because it happened so fast, when we run this program, for a brief instant, it says hello from Bob here. Now, the next instruction the computer performs is this one. Now, this one creates a variable called message and assigns it the value, my name is Fred. And this next part is super important. When we run the following instruction, we're going to take the current value of the variable called MSG, and we're going to print that value. The computer has not reached this instruction yet. The computer doesn't even know that that's the next instruction. It only knows that it was told to modify the inner HTML, the stuff that goes right here in the paragraph, to make it equal to the current value of the variable called MSG. And at that time, this is the value. My name is Fred. Now, after that, we run this instruction where we go ahead and change the value in the variable message. But this was already done. The computer's not going to go backwards and change it. So here's my question is, how do we get the computer to actually put I want ice cream right here? What do we have to do? Put your guesses inside of chat. This is a variable, and its value is, I want to get ice cream. Now, a little while ago, this variable had a different value. But with this new value, how do we get this to print out on the screen? Totally right, Matthew. You said repeat the code. This code right here, go ahead and copy this whole line right here. Go to the end and paste it. And now we're going to print the current value stored in the variable called message. Go ahead and run your code. And now it says, I want to get ice cream. I hope that helped. The big principle here is the computer only does one thing at a time, and it does those things in the exact order it is directed to. And until it reaches an instruction, it's not even aware of the instruction. It can't, quote unquote, read ahead. It can only deal with the information it's given up to that exact point in time. If the information is going to change later, the computer program has no idea that that's going to occur. We do, because we can read the code. We could read right here and go, hey, we changed the value of the variable called MSG. The computer literally doesn't know that. Why? Because it hadn't gotten there yet. When it was executing this instruction, all it had was the value of MSG at that point in time. Knowing that this is how it works can help you dramatically when you're reading through code and trying to figure out what it does. All right, let's move on to another element of a computer program, which is the ability for your computer program to make decisions. So we're going to come up with a basic idea. The game we're going to use, by the way, is this. It's called Simon Says. You're not going to do this. Don't follow along. I'm just going to show you something, okay? We go here. Don't worry about changing your code. Don't change your code at all. I'm changing my code because I want to. Here is a Simon Says game. And I'm trying to repeat what it does. So it went, did it work? Green, green, yellow. Green, green, yellow. Did I do it right? Green, green, yellow, red. Green, green, yellow, red. Green, green, yellow, red, green. Green, green, yellow, red, green. All right, I'm not going to play until I lose because I was really good at this as a kid. Okay, so this is the game. Okay, I just wanted to show you this so we can have some context. So I do all that because now, if I do now we're back to the same code. I want to come up with an example for you of when will we need to make a decision. Well, clearly, there's the final decision of, did the user replicate the exact pattern? Was there repeat? Did they repeat the exact pattern? So, if they did repeat the pattern, then they get to keep playing. If they didn't repeat the pattern correctly, then they lose. That's a decision that has to be made at that exact moment while someone's playing the game. Every time the user tries to replicate the exact color pattern that was done, your program has to be able to make a decision. Did they get it right? Great, they get to keep playing. Did they get it wrong? Sorry, game over. I'm going to show you how to make that decision. So let's go again to the very bottom of your code. It's this final document.getElementById, and then hit enter. Hit enter a couple of times just to give ourselves some room. The blank lines don't do anything. They're just going to make it a little more readable. So let's go up one line, and we are about to have the computer make the decision. Now I'm going to introduce a really cool thing, which is called comments. If I go dash dash like this is a comment. If we run the code, nothing changes. This is not an instruction in JavaScript. It's called a comment, and it's just there for you reading this program to understand some things better. So instead of saying this is a comment, let's just put down make a decision. There's your comment. Go ahead and put that in. And now let's make a decision. First, we need a variable that's going to hold something really important. And that thing that's important is, did the user or did the user not repeat the pattern correctly? It's going to be, the value in that variable is going to be either true or false. It's cut and dry. Either they repeated the pattern perfectly or they didn't. It's either true or it's false. So let's make a variable. I'm going to choose for this variable, we're going to call it correct. That's the name of the variable. I get to choose the names of my variables. I can call it Erik. I can call it foobar. I call it whatever I want. I like a variable name that kind of indicates some of the logic involved. So we're going to use a variable name called correct. And let's say we can give it a value. So hit a space and then equals. And let's do true with a semicolon. I did too many spaces. Sorry about that. Oh, I forgot the word var. I apologize. So there's the correct line of code. I was coding and talking at the same time. Always a mistake. Says the guy who does that over and over again. So we've made a variable called correct. Remember, that's called initializing the variable. This is the initialize the variable part. And then we've assigned it a value. The value we've assigned it is true. We're going to pretend that the player actually got the pattern correct. Now, what do we want to do if that is true? Well, they get to keep on playing. All we're going to do for the purposes of teaching you this fundamental of how to get the computer to make a decision, how to do these control and branching things, we're just going to print on the page, keep playing. That's all. We're just going to print keep playing. How do you get the computer to decide to do that, though? Well, here's how you do it. Hit enter, and we're going to use a special instruction in JavaScript, which is if. And immediately after this, put an open and close parentheses. No space between the if and the opening parenthesis. Now, put your cursor right in between, and let's talk about what goes in here. It's actually a good time to talk about another really important concept in JavaScript, which is this. Lots of the pre-built instructions in JavaScript that you're going to use need some information in order to do their job. For example, this is a pre-built instruction in JavaScript, this get element by ID. I didn't make that. You didn't make it. It's just given to us in the JavaScript language. And it's pretty clear what it does if you've been paying attention. This instruction reads through the whole page and finds something on the page that has that ID. So this instruction clearly needs to be given some information in order to do its job. We call that passing in the information. This is the instruction, and we're passing information into the instruction. The information in this case is the word demo. By the way, the information inside these parentheses is called a parameter. It's a special programming word. So this built-in instruction, get element by ID, takes a parameter, and that parameter is some text. If that text is found in something on the page, then we can control that thing on the page. We've been doing that for a few minutes here now. We've been finding this thing on the page, the paragraph, and we've been controlling what's the content inside it. We've done that 3 times now. Why do I explain that? Well, because this other instruction here called if, it needs information in order to do its job. Now, what this instruction needs is information that can be evaluated as either true or false, period. No maybe, no ish, just information that can be evaluated and determined whether it's true or false. So what we care about here is the person's attempt, did they get it correct? Is that true or not? Did they get the pattern correct? In fact, I think I'm going to change this. Everybody change the name of their variable to pattern. I like that better. We're just, again, you get to choose the name of your variables. Pattern makes more sense to me. So inside this parentheses, I'm going to write this all out. I want you to follow along, and then we'll explain it. Pattern, P-A-T-T-E-R-N, you should spell it right. 2 equal signs, and then true. Now, I'm going to explain what this is. We have 2 pieces of data on either side of this weird symbol. This symbol is not the same as a single equal sign. It does a completely different thing in JavaScript. We kind of know already what this single equal sign does. It assigns a value to a variable. Here, we made a variable called message, and we assigned it a value of my name is Fred. Here, we took that variable of message, which had already been created, and we assigned it a different value. So we're used to this assignment instruction. This double equals is not the same thing at all. Jeremy says, you get to choose variable names, but hopefully the poor person editing your code knows what they mean. Thank you. You're right. I've seen people that create variables with the most horrible names. Like this message, like, don't do this. Don't change your code. Don't change your code. Just watch. I've seen people that would go, variable's name is M. Variable name here is P. Like, that's horrible. No one can tell what you mean. Make your variable names have some significance. That was a really good point, Jeremy. All right, so back to what I was talking about here. This little symbol of 2 equal signs, one after the other, is a special symbol in JavaScript. It's called a comparison symbol. And what this symbol says to the computer is, listen, on either side of this symbol are 2 different pieces of data. I need you to compare them and see whether they are exactly equal to each other. That's what this instruction is. This thing that's highlighted, the 2 equal symbols, is actually an instruction in JavaScript. It says to JavaScript, compare these 2 pieces of data, and if they are equal to each other, then give me a true. If they are not equal to each other, give me a false. That's what it does. And this line of code is magic. It's how we can control a computer to only do what we want it to do in a specific exact situation and not do it if we don't have that exact situation. It makes your program extremely powerful because you can have a computer program make a decision. So here's the next part of what we need to do. We have on this line of code right here, this is a control instruction. If is a control instruction. And what I mean precisely is we're about to control whether or not the computer performs one of 2 available courses of action. But we haven't actually written the 2 courses of action. We need to. Let's write the first course of action, which is, what do we do if the value of the variable called pattern actually is equal to true? And we all know it is right now because we already assigned the value true. But what do we do? Well, you need a way. Now this next part is another one of those really important things. In almost every programming language, the following mechanism is needed. How do we write some instructions and indicate that those instructions are only to be performed in a specific situation? How do we sort of put a wall around them and only let the computer inside the wall in a specific situation? How do we mark off those instructions? In JavaScript, we do it with a special symbol, hit enter, and it's a curly bracket. You'll find it just above the enter key to the left. You have to hold down shift, and there's a curly bracket. And then I want you to hit enter 2 times and hit the other curly bracket symbol. And then go back up inside them. You're absolutely right, Matthew. That was spot on. Now, this is the principle. And if you grasp this principle, your ability to read JavaScript code and understand what's going on goes through the roof. We can put instructions inside these curly brackets, and those instructions are only going to happen if the value of the variable pattern is equal to true. If the value of the variable pattern is false, we are not going to do the instructions inside these curly brackets. This is how we control which of 2 or more courses of action are followed. We call those courses of actions that are available branches, like you branch off of a trunk, right? So we're going to write a branch. Everything inside these curly brackets is your branch. Now, we could start writing the instruction right now, but for readability, what's recommended in JavaScript is to hit space a couple of times just to make it easier to read your code. The 2 spaces don't do anything. The computer doesn't care in JavaScript. It just makes it easier for us to read our code. So again, in the actual game, Simon Says, that I showed you a few minutes ago, this is going to be handled with a much more complex bit of logic. For our purposes, all we want to do is just change what's shown on the screen to say, keep playing. Because if they did the pattern correctly, they get to keep playing. So we're going to watch what I'm copying. I'm copying all of this. We've used this before. Copy all of that with a Control-C or a Command-C and paste it down inside here. And we all know what this is going to do. It's going to change what gets printed on the screen. Do a quote and say, keep playing. But again, spell it correctly. And put a semicolon at the end. When you've got all that situated, go ahead and run this code. It's not working and I made a mistake and I want to find out why. Give me a second. Where's my mistake? I've got a code error. Give me a second. I don't memorize syntax, so I've got to look this up. Sorry. Oh, you don't capitalize. I've been doing Python too much. Okay. Change. See it, look at it turn blue. Change true to lowercase. And now when we run it, it works. Here's the change I made is I had capitalized true, and JavaScript, something being true is in lowercase. Thank you. My apologies. So let's get back to where we were because I distracted us. Totally my fault. I want to explain the value here again of what we're doing. We are saying with this line of code, we're going to control what the computer does next. If and only if the value of the variable pattern is equal to true, only if that is true, are we going to do this instruction that's inside the curly braces. Now, okay, Mark says your program is not working at all. Here's what you look at. Okay, it was working before, so the important things are, did you declare a variable and are using only one equal symbol to make it true and is true lowercase? Next thing is, do you use the same variable name inside these parentheses with the if instruction? And are you using this equality symbol and is true lowercase? Next thing is, do you have an opening curly brace and a closing curly brace? And finally, did you copy this correctly and then put some text in there? Check those things, Mark. That's probably where the mistake is. I'm going to give a second for him to catch up while I also take a sip of water. And now we're going to get into what to do if the value of pattern. Oh, earlier in the code, Mark? Well, take a look at what we have here because it's all working. Something in here is off. Look through every single individual character. There's something. And if you, Mark, if you can't find it, don't worry. Just watch and learn, like I said earlier on. You're still going to learn some really valuable stuff here, okay? So let's talk about a really important thing. We have only handled one of the branches we need. We're making a decision with this control instruction called if. We're making a decision. And we provided what the computer should do if the decision is true. But what if it's false? Well, here's how you do that. Go to the end here and type else. Else pairs up with the if to let you do the second branch. And hit enter. And now, same thing. Give yourself the opening curly brace, a couple of lines, and the closing curly brace. And now we can define another branch of code. This branch of code is only going to happen if the value pattern is not true. So what do we want to have go in here? Well, first of all, hit space a couple of times just for readability. And copy this whole line here from inside the first branch. Paste it in. And just change the text to say, you lose. Give me an exclamation point. I'm feeling aggressive today. Now, when we run this code, it's still going to say keep playing. Why? Because the value of the variable called pattern is true. So when we run our if, pattern is true, and so we go to this branch of code. Well, now, everybody pay attention to what I'm doing. Change the value of pattern to false. And then run the code. And now it says you lose. Again, I know it's a very straightforward example, but it is powerful. We've built a program that can make a decision. And based on the results of that decision, can do one of two or more possible courses of action. This is what makes computers so powerful. They can process data and make decisions. And this is how you do it. All right. Let's go to one of my favorite things in the whole world, which is subprograms. We talked about this earlier. They are essentially programs within programs. So let's just talk about this concept. We just built these, let's see, 1, 2, 3, 4, 5, 6, 7, 8 lines of code. These 8 lines of code, again, they did something really cool. They let us make a decision. Did the player of the game successfully repeat the pattern? If they did, they get to keep playing. If they didn't, they lose. Well, here's the problem. We have to make that decision every time the player attempts to repeat the pattern. I don't want to repeat those 8 lines of code 100 times in my program because they're the same exact instructions every time. So now we need a subprogram. We need to take these 8 lines of code and we need to put them inside a box and put a name on the outside of that box. And that way, whenever we want those 8 lines of code to be used, we can just call on that box, that subprogram, and say, hey, do what's inside this box. Do the instructions inside this subprogram. And when you're done, come back where you left off. That's what we're going to build. In JavaScript, this subprogram thing is called a function. A function is a repeatable chunk of code that you can call on whenever you need it. Let's make a function. So go to the bottom here on an empty line and type the word function. We need a name for the box. We need a name for this repeatable set of code. We need a name for our function. Let's come up with one. We're going to call it check win. Check if they won, that's all. Well, it isn't if they won, actually. We're going to check correct. Check correct. That's what I want to call it. Did they get the pattern correct? Now, this next part is another one of those critical things. When you make one of these subprograms, you can think of it like this. The computer program is going through one instruction after the next, and all of a sudden it hits the point where you as the programmer, need whatever's over in your subprogram to be performed. Very often, that subprogram needs to be given some information in order to do its job. The information that is given is called an argument. I know it's a silly word, it's a math word, but the information that's going to be given is called an argument. So when we're creating one of these subprograms, again, they're called functions in JavaScript. When we're creating one of these functions, we need to put down whether or not this function will need some information when it does its job. And that information goes inside of parentheses. So put yourself a couple parentheses right after the name of the function. The name of the function, of course, is check correct. So inside this parentheses, we're going to put a name for our argument. I want this argument to be called attempt because we're going to pass in their attempt. A pattern gets shown on the screen and the user tries or attempts to repeat that pattern. So we're going to put their attempt, we're going to give the attempt to this function. We're going to say, hey, function check correct. Here's what happened when the user tried to repeat the pattern. And what we're going to tell them is, yes, they repeated it, or no, they didn't. And we're going to call that attempt. We get to come up with a name. Again, We could call this Erik, which would be weird, or guess, or repeat. We can call it whatever we want. But we have to give that information to this subprogram, or the subprogram can't even do its job. It's like, wait a minute. You want me to make a decision about whether to keep playing or to end the game. Well, you have to tell me what happened when the player tried to repeat the pattern. Did they repeat it or not? If you don't tell me that, I can't make a decision. And so we're putting that in as what we call an argument. All right, here's the next part that's really important. Again, if we went back to the original 5 elements of a computer program, and we talked about subprogram, I said it's a set of instructions that you're going to repeat when you need them. Well, what are the instructions? Let's do the instructions. I want you to hit enter. And oddly enough, we're going to do a opening curly bracket or brace and a closing curly brace. And inside here are the instructions that we want to repeat over and over again. Well, we know what we want to do. We need to take the information that was given us. What was given to us is yes or no. Did the user actually successfully repeat the pattern? And if they did, then they can keep playing. If they didn't, then the game's over and they lose. So we're going to take that information, the information that was given to our subprogram, and we're going to make a decision based on it. So go inside these curly brackets. And again, hit a couple spaces just for readability. And let's start making a decision. We use an if. And in here, we're going to check this argument that we were given, which we're calling attempt. Is it equal to true? It's the same sort of approach as before, but now we're setting these instructions inside of these curly braces. Now we're saying these instructions are only going to happen, they're only going to happen when we ask for this check correct subprogram to be run. So what do we do if the value of this variable called attempt is actually true? Well, we kind of know. Hit enter and do an open curly brace, a couple of lines, and a closed curly brace, just like we did before. And go in here, hit spacebar a couple of times, again, just for readability. It doesn't change how the program works. Well, we know what we're going to do. We're going to print something to the screen. So copy this code that lets you print something to the screen. And what do we want to print? Well, I think we're going to be a little nicer here. And we're going to say, you got it correct. Keep playing. I'm going to give you a little more room to read that. I'll give you a moment to get caught up. And now let's do the else. Go right here after the closing curly brace, hit enter, and let's do the other branch. Open curly brace, hit enter a couple times, close curly brace. Go in between them, hit the space bar a couple times, again, just for readability. And we know what to do here. Paste that same code in. And again, we're going to be a little more friendly. I'm going to say, sorry, that was not correct. Game over. Again, I'm being a little more friendly. I'll wait for everybody to get caught up. And we're going to talk through this next thing we're going to cover. We're almost done with the coding portion here, okay? This next thing we're going to cover, if you don't catch this, your ability to study JavaScript is going to be horrifically impaired, and you're going to want to beat your head against the wall. So if you pay attention to anything, pay attention to this next part. It's critical. Look at everything I've highlighted right here. We've made a function. Now, again, when I talked about the 5 elements of a computer program, I said that one of them was a subprogram, and that's correct. In JavaScript, those subprograms are called functions. Different programming languages have different terms for the same thing. In some, they're called functions. In some, they're called methods. In some, they're called subroutines. In some, they're actually just called subprograms. It's all the same concept. So in JavaScript, they're called functions. We made a function. We gave a name to the function. It was check correct. We clarified that we're going to have to pass some information into this function whenever we use it. We're going to call that information attempt. We wrote some code that, based on the information passed in, this argument called attempt, we're going to make some decisions. If the value of attempt that was passed in is true, then we're going to do this branch of code. Otherwise, we're going to do this branch of code. This is a pretty cool thing. Now, I would like for you to put into chat, tell me exactly what's going to print right here on the screen when we run our code. Give me your guess on what's going to print on the screen right here when we run our code. That's not correct, Matthew. And I'll show you why. That is correct, Norma. You forgot the exclamation point, but it is correct. So question, and you don't have to answer. Did any of you think that what was going to print was this? Let me explain the basic principle here. What we've done by creating a function called check correct, all we've really done is we've created a set of computer instructions that could be executed later in the program if we ask for them to be executed. But we have not asked yet. All we've done in creating a function called check correct. It's exactly right, Matthew. Good job. So it isn't nothing. What does print is you lose, because that's where we were right here. All we've done in creating this function is we have defined some potential behavior in our program. There's potential work that could occur, but we've not asked for it to occur. How do you ask for it to occur? Well, in JavaScript, let's go down to the very bottom here. After our function definition, so go down here, hit enter just for readability. The way you ask for a function to be performed is you type out its name and give it the information it needs. So let's type out the name of the function. It is check correct. Make sure you spell it exactly the same as when you made the function. And in parentheses, let's give it some information. Let's give it the information false. We're saying the person did not repeat the pattern correctly. Run this, and look what gets printed. Sorry, that was not correct. Game over. Let's talk about exactly what occurs, because if you can follow this, your ability to study JavaScript and read through a program in JavaScript goes up a lot. Remember, the computer started at the top and did the first line of code, and then the second and third and fourth and fifth, all the way down. It got down to this line of code right here, function check correct. And it didn't actually do anything. No work occurred because all we're doing is we're making a function that could be used in the future. But then the computer went a little farther and it reached this line of code and went, oh, I know what this check correct thing is. This is a function that I was looking at earlier. Okay, so I'm going to run that function and I need this information right here that's being given to me. I'm going to take this information, false, and I'm going to run this function. So when we run the function, this argument that we're calling attempt, it now has a value. What value? The value we gave it. We gave it the value false. So attempt has a value of false. So now when we run this line of code, the value of attempt is false. And since that's not true, we do not do this branch of code. We go to the else and do this branch of code. So what does this mean? Let's say, go and change this to, sorry, I'm going to change this to true. And I want you to do something for me. I want you to copy this line of code after you changed it to true. Copy it. Whoa. And I want you to paste it like 5 different times. And then the 6th time, I want you to change it to false. This is how you'd actually use something like this in a program. Every single time a person tried to guess the pattern, you would call check correct and you'd tell check correct whether or not they got it right. They got it right once, they got it right twice, they got it right a 3rd time, they got it right a 4th time, they got it right a 5th time, they got it right a 6th time. On the 7th time, they got it wrong. And each time they made an attempt, you would call this function. You call the function check correct. That's what it means when you want to use a function. The word we use is calling it. You're calling on the function to do its job. So we keep calling the check correct function, and each time we're telling the check correct function whether or not the player guessed correctly. It's true, it's true, it's true, it's true, it's true, it's true, until it's false. Now, I don't know about you, I like typing one line of code and not 8 over and over and over again. And that's part of the value of a function. One last value, and then we'll move on to something else. Let's say we did want to be harsh and we wanted to change the message. And we wanted to say, sorry, you lose. We only have to change that one place. We get to change it inside our function. And now every place we use our function, our new change is reflected. It makes it so much easier to maintain your program over time. All right. That was fun. Let's move on to the next stage of this. I want you to get the full set of code. So, Cheska, can you drop this link in? I think you've got it. I'm going to drop it in as well. Grab that link. And I want everybody to copy all this code. Do like a Control A and a Control C. If you're on a Mac, it's Command A, Command C. Copy all this code. Go back over to your editor. Select everything and paste in your new code. And then I want you to play the game for a few minutes. Run it. All right, it's red. Red, blue. Red, blue, red. Red, blue, red, blue, red, red, yellow. red, blue, red, yellow, green. Okay, I have to intentionally lose here. This is fun. Red, red, yellow, blue. Up. Wrong sequence, game over. Okay, I lost. All right, so I want to show you a few things about this code because you should be able to understand some parts of it decently now that we've gone over some of this. First, everybody pay attention to this. I want you to scroll down to where we get to the script portion. There it is, script. So we have some variables that are being made. Const is another way to create a variable in JavaScript. Let is another way to create a variable in JavaScript. So we've got a variable called sequence. It's an array where we're going to store the sequence of colors. Okay. We have a player sequence. It's an array to store the player's sequence. Like, what did they choose? We have a variable called canClick. We're going to either allow or disallow the user clicking. Oh, look, we have a variable that is colors, and it contains green, red, yellow, and blue. So you can follow along with a bunch of variables. Oh, look, we're making a function. It's called animateBox. Okay. Here's another function called updateScore. We've got a function when someone clicks on one of the boxes. So you could read through this, and with a bit of time and some research, you could understand how this program works. And again, we're not going to go through the whole thing, but you have this code now. It's yours. It's a fun game to play, by the way. I happen to love Simon Says, okay? And just using what we covered tonight, you could go through and start to really understand a bit more about JavaScript. But I've got something really cool for you here in a few minutes that will help you learn it even better. So bear with me. All right, let's go here. Let's go back here. All right. Now, I think I captured all of the questions, but I want to give an opportunity. I know we're going a little bit over, and I appreciate you all being here. If you have any questions that we didn't answer, pop them in chat right now. All right. So I want to take a bit of a moment here to explain a bit about what our programs are actually like, how they work. Norma, the script is in that link. It's the Google Docs link that we've sent at 8:33 p.m. Here it is again, I think. Let me copy the link. There it is, Norma. So there's the link. All right, so we have a large number of boot camps here. We actually have 12 online boot camps, and they cover, as you can see, all kinds of subjects. Everything from artificial intelligence, right here, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. In fact, we have more certification programs than any other boot camp on earth. But here's the important part. These boot camps are self-paced, but they're also instructor supported. So if you learn at a different pace from someone else, you're going to be okay. They're also very flexible. You set your own study schedule, and you can enroll 365 days a year. You don't have to wait. The content on the boot camps is very well-rounded. It's extremely in-depth, and they're also affordable. They're priced under the national average. A real important point is that every single one of these programs you see includes job placement training and job placement assistance. More on that in a moment. But most importantly, these programs are designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd. We consistently land on every major best coding bootcamp list out there. Our average review rating across all of the major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. We're very proud of that. Now, if you don't work in tech yet, and you're thinking about it, here's a couple of reasons why you might want to consider it. First of all, technology as an industry has really great work-life balance. Remote work is very possible. It's also a very creative industry. It's an industry where you can take a lot of personal pride in your work. You're solving difficult problems. You're producing a lot of value for organizations. And finally, it's a really stable industry that pays really well. And as long as you keep learning and advancing your skills, there's regular increases in pay. The average wage for a software developer in America is $120,000 a year. That's pretty cool. Now, that said, there are barriers to doing a boot camp. There's 3 routes into technology: self-study, college or university, and a boot camp. We run a boot camp, so we know these really well, and there are barriers. The first one is money. It takes thousands of dollars to get through a boot camp. What we've done to try to handle that is provide you with multiple financing options, including a very large upfront discount if you can just pay for the whole thing upfront. And if you can't, a bunch of different monthly payment options, no matter what your credit is like. But the big picture here is that, yes, there's money involved in doing a boot camp, but it's genuinely an investment in yourself. You're giving yourself a set of skills that's always going to be in demand and pays well. Oh, Norma, that's fantastic. Norma is doing our training through one of our partners up in Canada. I'm so glad to see you here. That's awesome. Okay. Another barrier to getting through a boot camp is time. There's a lot of material to get through. Now, some boot camps try to handle this with what they call a cohort model. That means you can sign up, but you can't start right away. They wait until they get a big group and everybody starts on the same day as what's called a cohort. And then they all move through the boot camp curriculum at the same pace. I'm not going to hold anything back. I can't stand that training model. I learn at a different pace than everybody else. Some things I learn really fast, and other things I just crawl through. And the last thing I want is for the class to move on and I'm left behind. And so we don't do that at all. Our programs are fully online and they're self-paced, which means you can choose your study schedule, and you can even do part-time, and you can even fit your study in around other things, like another job, like a job or other school that you're doing. Finally, another very real barrier to getting through boot camp is you do need to have some technical interest or ability. Now, if you've ever felt like maybe that's a real rough spot for you, or maybe you're not smart enough for it, or it's somehow super complex, that is not you. Some technology education materials are frankly too hard. And that happens because some educators assume prior knowledge on the part of the student. We don't do that. You don't have to be a nerd to get through our programs. No technical background is needed to enroll and get through the programs. Now, with all that said, I've got some questions for you. Are you possibly working a dead-end job, a job where the income ceiling is not where you want it to be? You want to make more than that? Or maybe you're even unemployed, or maybe it's important to you to work from home and the current career you're in will never accommodate working from home. Or your work-life balance is skewed and you want more time with your loved ones. The whole question is it time for a career change? And if it is, well, we can be the answer. The Tech Academy, we are career change experts. That's what we do. We provide a route into technology for everyone. That's what that bridge right there represents. We've got over a decade of experience in breaking people into tech. Most of our graduates make on average $30 an hour in their first job, and it goes up from there. We've got over 1,000 graduates in tech working at everywhere from small businesses to huge corporations like Nike or Facebook or Disney or Uber or Epic Games. We're proud of those because it's really cool. But frankly, everybody needs tech. Everybody needs IT workers. So as a reminder, we have open enrollment. You can start anytime. And I do encourage you to enroll now. I will say this. We started this a few months ago, just piloted some aspects of it, and it's working. So if you enroll in the month of October, we will give you, if you pay for your tuition up front, we'll give you a massive 50% off tuition discount. That can save you $5,000 to $10,000 if you can just pay up front. Also, if you need a laptop to do your studies, if you're in America, we will ship you a refurbished laptop that's yours to keep that you can do your studies on. Also, if you enroll in October, we'll pay your sales tax. No matter where you live, you don't have to pay it. It does get paid. We take care of it. Also, we'll send you copies of the books that'll help you get through our program. We've written a lot of books, okay, including an Intro to Coding book, the Computers and Technology Simplified book, our Technology Basics Dictionary. We'll have copies of those so you can get through your program more easily. We'll also send you a copy of our career planning guide. We're really proud of this. We didn't see anything out there that would help someone navigate the first 3 years of their career, and so we wrote it. What do you do during the first 6 months, 18 months, 36 months of your career? How do you navigate that early period to give yourself a really solid foundation for a long-term successful career? We lay all of that out in our career planning guide, and you get a free copy of that. You also get 3 months of free access to what's called the Tech Academy Accelerator. I love delivering this. The Accelerator is a subscription service that gives you access to over 100 free educational videos. It also gives you access to our weekly accelerator workshops, which are a blast. I lead these. They are open video, open chat, open voice. It's a conversation back and forth, and we build things. Each week, we dive deep into some technical subject, whether it's like an actual programming language or a new framework or how to successfully get side jobs, everything about being a professional technologist. I just dump everything I have in my brain and my experience into those accelerators. You get 3 months of free access to that program. And probably most importantly, if you enroll in October, we're going to give you unlimited job placement assistance. As long as it takes you to get that first job, our professional job placement personnel are there for you. So how do you do this? Well, here's the login form. Jessica's going to drop a link to that into the chat right now. Okay, there it is. And if you click on that and fill out the simple form, it's going to take you through a series of steps that tell you all about the school. How are our programs put together? What do you learn in what order? Why is it in that order? How do you do your practical exercises? How do you interact with instructors? Everything's laid out in those steps so that you are fully informed about the school. So fill that out. I'm going to take a sip of water, and then we're going to get your free gift in a moment. Thank you for sticking around. All right, a brief word about our referral program. Since our graduates really are very happy with us, referrals from students and graduates have been one of the top enrollment sources for us for years. And so we put in place a commission payment of 5%. But that's not just for students and graduates. You can do that too. If you, in a minute, I'm going to give you an email to send in to request the free gift. You can include referral information in there about people you think we should be talking to. And if they end up signing up for one of the boot camps, as soon as they pay, we're going to send you a commission check, which is pretty cool. You'll deserve it. Brief word about our books and our dictionary. We've published 7 books, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a Technology Basics Dictionary, the Project Management Handbook, and one of my favorite things we ever wrote, You Are Not Stupid, Computers and Technology Simplified. It's a vital book for anybody in the modern age. And now our free gift. It is our Introduction to JavaScript book. This thing rocks. It'll lead you through a lot more than we can cover in an hour and a half about JavaScript. And it expands upon those 5 fundamental elements of any computer program to a great degree. It's really powerful. Jack and I put a lot of work into this, and we'll send you a copy for free to your house. Now, here's how you do it. You can email us at the email address that Cheska dropped into chat, but you have to include your mailing address or we can't send it to you. But if you do that, we're going to give you a free copy of our book. So I'll give a moment for people to grab that email address. I also want to mention our link tree. If you're not familiar with Linktree, it's a website where you can aggregate all of the links for your business. Cheska's going to drop that into chat right now. If you click on there, it'll take you to every link conceivable for the school, including links to our free educational YouTube videos, right? There it is in chat, okay? When you click on that, you're going to see there's links to our YouTube channel, links to our books in our dictionary, links to our upcoming meetups, because we want to see you at more of these classes, links to all of our social media. So please follow us on social media, come to these free classes, read the books, and just figure out whether or not technology is right for you. And if it is, then find out more about our schools. We're here to help you out. So thank you so much for attending. Thanks for going over a little bit. That was I just kind of got carried away on teaching some of the programming stuff, and I hope that was helpful to you. If you enjoy anything about how these classes go, then find out more about the school. And otherwise, thanks for taking a Friday night to do this. You could be doing anything on a Friday night, and you chose to spend it with us, and I really appreciate it. Thanks, Jeremy. Good to see you. You too, Crystal. Bye-bye, all. Have a good night.